NS for Networking is the podcast for college students, junior networkers, and anyone else who wants to learn more about data networking. Routers and switches and packets, oh my. I am Ethan Banks, a network engineer who's seen a thing or two, along with Holly Metlitsky, a newer networker who knows a lot but is learning more as she goes along. You can connect with us on LinkedIn, and please do. You can find our links at packetpushers.net/hosts. Our topic today is the default gateway. What is the default gateway for? How does the system configured with the default gateway know when to use it? What happens when there is no default gateway configured? And what happens if you put in the wrong default gateway, Holly? So we're gonna dig into this. So when we talk about the default gateway, what are we talking about, Holly? Where are we? Like, we've talked about the OSI stack and stuff. Kind of where are we?
So this is all around routing. So we're looking at layer 3. You're looking at, things related to IP addresses and mostly just routers specifically.
Yeah, the whole default gateway thing, we are exactly talking about routing. We got to get traffic from our IP host to another IP host that's on a different network. And by different network, if we remember that the internet is a network of networks, then a gateway, also known as a router, knows how to move traffic between different networks. So I don't know if you've run into the term gateway all that much other than where you see default gateway, but in networking, gateway and router pretty much always mean the same thing. I say pretty much because it seems like there's always an exception, although I can't think of one off the top of my head. Gateway, router.
It's funny because maybe it's just the way that I've gone about learning all my networking stuff, but I don't put the two together. Which I think is wrong in my manner of thinking. And it's kind of the same thing. But when I think of like the default gateway, I guess I'm thinking about the IP linked to that gateway and not necessarily the box itself. And I think that just might be because I'm mostly in the CLI sometimes and I'm not thinking about the actual box.
Well, okay. Yeah. So I think what could maybe update how your brain thinks about this would be to consider what is the point of sending something to a default gateway. Like if I got to send traffic to a default gateway, what is it that I expect the default gateway to do? Yeah.
And I mean, in that sense, you forwarding that traffic out of your network to another network. So
and so that gateway has to know how to do that, right? So let's take the really straightforward example that a lot of us listening to this can relate to, just our home networks. We've got some kind of an internet connection at home. We went to a store like, I don't know, in America, Best Buy maybe, and bought a router, Walmart. We brought home a gateway router that we plug our ISP into, and then we'll look at the back of the box. It'll say, here's your WAN link. And then on the other side, we could either plug in directly. There's probably some ports on this thing, or it's a Wi-Fi device. It's got antennas, and we connect to the Wi-Fi coming from the device. That box, that's your gateway. That is going to be your default gateway that everything that's on your home network, all your laptops and your streaming devices and your gaming consoles and all that stuff, to get to the internet, how are they doing it? Well, they're going to have a default gateway configured on them, and that default gateway, that IP address, is going to be that device, that one magical thing that sits in between you and the internet. So that box, that device has got to know, okay, I just received all this traffic from the streaming device because someone's fired up Netflix and is trying to figure out what show they want to watch tonight. Well, how does it know? What good would it be if it didn't know how to connect to the internet? Let's put it that way. It wouldn't do us much good, right? So it's a router, right? That's the thing. It's a router that's got routing tables, and it knows, to talk to the internet, I have these tables I can look up, and I have to send traffic to upstream to the ISP somewhere would be where it's sending traffic to.
Yeah, which I think from that point, using the word gateway makes a lot of sense because it's exactly that. It's connecting two networks. It's the gateway out. But I think then we get to the word default. And maybe we need to dig into that a little bit.
Well, so why is the default? Why is the word default in default gateway? Do you have a thought?
I mean, just from a logical perspective, anything that's default is something that you can always revert back to, and it's it should be correct. It should be, when all else fails, this is something you can rely on, and that's definitely going to work.
Yeah.
So,
and that's true. And it implies something else interesting about networks, in that you could have more than one gateway connected to your network segment. The default gateway would be the one you use if you don't have a more specific destination in mind. So here's another thing about routing tables. Your laptop has a routing table in it. It does, as part of its IP stack. In fact, if you were to if you wanted to see the routing table, you could use a command that works on Mac OS. I don't know if Windows is exactly this. It's been a long time since I've been on a Windows box, but netstat is the command. Netstat, and then there's a bunch of parameters and different things you can look at with the netstat command at the command line. But if you look at netstat-rn, and then -f for the address family of internet, that will dump your IPv4 routing table. If you've never heard that before, you're not going to remember that. That's okay. You can do a search and say, netstat. How do I use netstat to show me the routing table? And you get a bunch of stuff back that'll explain it to you. But
yeah, I plugged that into mine just to see, what's going on. Quite impressed how busy my routing table is on my laptop. But the first thing that pops up under that table, it's got a couple headers. It's got destination, gateway, flags, whatever. But the destination is default, and I've got a gateway with an IP address that's sitting there.
You could actually, there's the route command you can use to actually add routes to your host and say, well, for this specific, the 10.10.10.10 network, I want to send to this other gateway that's different from the default gateway. That's a thing. You could have multiple routers on your segment. It's not typically the way a network is designed, but it is possible. And thus, you end up with a default gateway that's, if I don't have any more specific routes that points to some other gateways, I'll just use the default gateway. So everything I don't have a more specific route for gets funneled that direction, the default gateway, which, go ahead.
Yeah. No, so the way you're saying that, everything else gets funneled in. So just to comment on that. So if I think about this, it's kind of like, if you don't have a more specific route, or maybe you have a route that you don't really know, it's going out of your network, but you're not quite sure where it's going to, that's kind of where you fall back on your default gateway. But then my next question around that is, perhaps maybe you've got options that are more optimal than your default gateway. Would you rather take a more optimal route out of wherever you're going?
You would. And there's different ways that can be handled. Like, let's say your host only knows about the default gateway because we haven't programmed any other gateways into it. We haven't manipulated our host routing table with any other routes. It could be that you send that traffic to the default gateway going, because I don't know, and you're the only gateway I got, so what do you think? Yeah. And that router goes, oh, I'm not the best route for this. I'm not the best gateway for this specific destination. You will get a message back from the router to your host going, there's a better route for this, or there's a better gateway for this route. Use this gateway instead. And that would come in the form of an ICMP message, Internet Control Message Protocol. It's a specific type of ICMP message that would be returned to you in that case. And then your operating system, your Mac or whatever, would need to know what to do with that and react to that message. But that could happen, yeah.
Okay, yeah, that makes sense.
It's about efficiency, these are old school problems. So now another point to make here when we're talking about default gateway here, both IPv4 and IPv6 have default gateways, but they work a little differently from one another. IPv4 works one way and IPv6 works a little differently when we try to answer this specific question. How does a system configured with a default gateway know when to use it? Because that is a question. Because you're like, well, we look at it and go, oh, well, that IP address is not on my network because I can just look at it and kind of know. But the computer doesn't work like on kind of know principles. It's got to do math or something. It's got to do a comparison operation. It's got to do something to figure this out. So let's talk about IPv4 first. And this introduces the concept of the subnet mask. Now,
Yeah.
you, Holly, were telling me you've got a whole bunch of certifications. So I know you've run into subnet masks and subnetting. You surely have. And you're nodding and your
Yes.
eyebrows are going up and you're rolling your eyes. Why is that?
It caused me a lot of maybe not confusion, but I've worked with binary, I've worked with hexadecimal, in high school, just learning about all these different numbering systems. But when you start getting into working with subnet masks and wrapping your head around the maths behind it, and perhaps understanding how a computer is taking that, for example, 192.168, whatever, that address, and it's not actually looking at it as a decimal number. It's looking at it in binary. So there's ones and zeros. So you have to understand, when doing subnet masks or subnetting IP addresses, how to look at it both from the perspective of decimal and kind of understand the binary side, because that's what the computer's understanding.
Yeah.
So it's a lot of fun.
Yeah.
A lot of math.
Well, yeah, it's not, it takes time to get your head around it. Once you get your head around it, you're like, oh, okay, I get it now. But it is hard because so a typical IP address is what we call dotted quad format for IP version 4, right? It's 4 numbers separated by a dotted quad. And that is a decimal representation of part of the binary number that's there. An IPv4 address is a 32-bit binary number. It's 32 positions, if you will, each position having either a 1 or a 0 in it. Humans don't remember that kind of stuff. And so it's like, wow, we need a decimal representation of this, or this is not going to work out at all. And again, so we ended up with the dotted quad thing. So the dotted quad takes that 32 bits of binary, carves it up into 4 fields of 8 bits apiece. And so we end up with the, 4. And so we end up with 8 bits making up the first number we see in decimal, and then another 8 bits making up the second, and et cetera, et cetera, et cetera. So for subnet masking and figuring out default gateway, forget all the stuff you know about the decimal and just go, oh, wait, this is binary, because everything that happens here is happening at the binary level that you care about. So the subnet mask, like a very common subnet mask, is 255, 255, 255, 0. That's kind of the classic subnet mask. Doesn't have to be that, but it's kind of the classic thing. That is part of the equation for the computer to figure out, well, is my destination address connected to my local network where I should just be able to put an address resolution protocol request out on the wire and figure out where they are and send an Ethernet frame to them? Or is it somewhere else where I need to forward it on to my default gateway and let my default gateway figure out where it is? The subnet mask is involved here.
And maybe you should just comment on what a subnet mask is, in case our listeners are new and don't know what it is. And it's telling you which part of that IP address is static and which are kind of variable. So it's saying, okay, we want to have in this network, I don't know, you want 30 IP addresses. So we're going to keep the first 2 bits, bytes, whatever. We're going to keep those stationary. We're going to have, 192.168. And then we're going to have the other 2 variable to create your subnet. And that mask is telling you which ones are going to remain stationary and which ones you're going to change to give each device their own individual IP address.
Static and dynamic is a good way to look at it. Another way that might work for you if you're listening is the address is any IP address is broken up into 2 sections: the network portion and the host portion. So the network portion would correspond to the static portion, Holly was saying, and the host portion would be the dynamic or variable portion that she was saying. You'll run into that in a lot of like networking books and stuff. They'll talk about the network part of the address versus the host part of the address. Another way to look at it. And the subnet mask, which is going to be in binary, a whole bunch of 1s until it's done. That marks the network portion of it, the rest of it being 0. So it's a 32-bit, in the case of IPv4, it's a 32-bit field with leading ones defining the network portion of the address and the rest being zeros defining the host or variable part of the address. So now if you're thinking about this in binary and you want to know what the subnet mask is actually, how it's used mathematically, well, what happens is, okay, so here's the math. We're going to do, first of all, a bitwise operation called XOR. And now if you're listening to this, you're going, wait, what is that? Just do a search for bitwise operators. You can look for XOR and OR. Those are bitwise operations that are very common, and they're very simple in what they do. In this case, we're using an XOR bitwise operation between the source address and the destination address. You're going to get a result that comes back. And again, we're doing all this in binary. So we're doing this at the ones and the zeros level. That result is then used with an AND bitwise operation with the subnet mask. And if the result you get from that is 0, then the host must be local. It's on the same network in the same broadcast domain. Hooray, I can just put an ARP on the wire and send it on. If the result is not 0, the traffic is forwarded to, it must be somewhere else. So I'm going to go ahead and forward the traffic to my default gateway. And if you listen to all that, and this is your first exposure to it, you're like, what are you even talking about? This is all bitwise operators and ands and ors and binary arithmetic. I'm frightened. This is maybe more than people need to know at this level, Holly. I don't know. I mean, do you really feel like they need to know this to understand what a default gateway does and what a subnet mask is for?
I'm really glad we've covered this, because I know what bitwise operations are, because I used to make little diagrams in IT in high school and with ones and zeros to understand, okay, if I have a 1 and a 1 and an AND operator, what's the outcome? If I have a 0 and a 1 and an XOR, what's the outcome? But I never understood why I was doing that or where it fitted in. I mean, I was told computers use this to make decisions or something, but I never actually understood what decision or where it fits in. I was just taught this concept, and it lives rent-free in my head with no application. So it's really nice to actually be like, oh, this is how a default gateway works. Because I think, again, often you're just like, okay, it's sending this and it makes a decision. But it's really interesting. And maybe this is like my super nerdy side coming out, but like, I love to understand the nitty-gritty of how it's making a decision, instead of somebody just telling you, oh, it goes through, the computer says yay or nay, and off it goes. Like, great, but it's a bunch of ones and zeros. How on earth is it making a choice? So it's not necessary, but it's fun to cover.
Yeah, it's good. It's good stuff to know. It is fun. And these operators, even if you've never heard of them before, are simple, and they have application in lots of different programming tasks. So for instance, I was a nerd in high school, and I was trying to write a text adventure game, which when I was a kid, those were fun games like Zork and Planetfall and stuff like that, where you'd go with anyway, I'll save you from that nerdery, but I was trying to write one myself, and I was trying to figure out, how do if I walk into a room in my game and I need to describe the characteristics of the room, like, does it have a door on the western wall? How would I store that? And found out that I could just store a number and then use the binary version of that number as an indicator of whether or not there was a door on the western wall, or whatever the characteristic was I was trying to store. And so the number describing the room is, I don't know, 254 or something like that. Then go do a binary, a bitwise operation, and go, if the result of this bitwise operation is 1, let's say, then I know that there's a door on the western wall. And it was just a neat way to, rather than having this endless table of variables, I could store all the characteristics about that room in one number, and then use bitwise operations to determine which of the binary switches I had flipped on to describe the characteristics of a given room. And there's lots of other programming applications where bitwise stuff comes up. But we are far afield now talking about default gateways. We definitely went down a rabbit hole, Holly. Okay, so we were talking about IP version 4. And if you remember earlier, I said that IP version 6 is a bit different. And I had to review this because it's been a long time since I thought about this, but IPv6 is more straightforward in how it determines whether or not it needs to use the default gateway. IPv6 compares the network portion of its IPv6 address with the same portion of the destination IPv6 address. And so if it's the same, hey, my network portion of my address and the network and the network portion of the destination address is it appears to be the same, then I'm going to assume they're on the same network and in the same broadcast domain, right? And if not, then I'm going to go ahead and forward to the default gateway. So here's another question for you, Holly. What happens when there is no default gateway configured?
Well, then how are you getting out of your own network? It's kind of like what you said, kind of going back to your door in your game, actually.
Right.
It doesn't know that there's a door there. So there's no way for that traffic to get out of its local network.
Yeah, it'll be, and you would get a message back, like if you were at a command line trying to use the ping command, a common command line utility to see if a remote destination is reachable. Like you could say ping google.com and you should get a response back. Well, ping would try to connect to that remote destination that's far away, but without a default gateway, it would be like, I can't get there. I don't know how to get there. And the message you see in your screen would be something like destination unreachable.
Yeah.
Like you tried to go there. I don't know how to get there. It's unreachable as far as I'm concerned. You might also see that if your internet service provider is down, but your home router is up. Like your Wi-Fi in the house is working, but your ISP is dead because reasons. And you try to do a ping, you might get a destination unreachable back telling you that basically you were okay. You were able to send to your default gateway that your home router, but your home router had no idea what happens next because the ISP is down. So you could get at that destination unreachable message might be something that you see. So kind of related and maybe an obvious question, but let's ask it anyway. What happens if you put in the wrong default gateway? If you were like manually configuring your default gateways and put in the wrong thing?
Which has definitely happened because sometimes a 1 happens to look like a 2. And if you try going back to the ping command, if you're trying to send traffic to that now wrong default gateway, it'll try send traffic out there. And perhaps if the destination is known from that gateway, it's going to send the traffic onto we don't know where. Or there might not be. And then again, it's not going to know what to do with it.
Yeah. If you've got the wrong IP address in for your default gateway, it's going to try to send it to that IP address. But if maybe that IP address belongs to someone on your local network, but that device is not a gateway device. It'd be like, why are you sending me this traffic? This is not for me. So there's a lot of different potential reactions that you might get there. Or there's no gateway, there's no IP address on the network that responds to that default gateway that you configure. There's just nothing out there. So your host would be like, hey, I'm trying to talk to the default gateway. So it's going to go through that ARP process we talked about in an earlier episode. And never get a response back and be like, I got nothing. So I think in that case, I think you would get your destination unreachable message. You might get a subtly different message as well. I'd have to experiment. I'm not sure, Holly, without clicking around.
I'm not, usually it's destination unreachable. Or sometimes it says can't resolve the host.
Yep, that could happen
another one I've come into.
Yeah, depending that could come up depending on what it is you're trying to reach and how it's configured. The practical side of it is it ain't going to work. That's for sure. If you got the wrong default gateway in there, things will happen. And if you put a packet sniffer, like we were talking about Wireshark in an earlier episode on the line, have some fun. Purposefully break some things with your default gateway configurations. Do it wrong and see what happens. See what the result is. Change your subnet mask to something incorrect that is not what you should have, so that your host is not forwarding traffic to the default gateway that it really should be if it wants to talk to them. Just mess around with stuff and watch what happens in Wireshark and see the different messages that go back and forth. Look at your poor workstation putting an ARP on the wire for a host that's never going to respond because it's not local. It's very sad. A lot of repeated ARPs with no response. Poor guy. And so send it.
Yeah, something I've seen as well, which I've done, is if you're configuring, like we spoke about, more specific routes that you wish for that packet to follow instead of going to your default gateway. But somehow your traffic is still you pinging that address, and somehow you're getting a response back, and you perform what's called a trace route to see, how is it getting out, and you can quickly realize that maybe you've configured the wrong static route or more specific route, and actually it's just going out your default gateway, which has happened to me a couple times. You think, cool, everything's up, everything's good, but it's taking the wrong path, and it's not actually doing what you intended. So there's a lot of ways to break things.
Yeah. But more to the point, you learned when you break things. So, if you are configuring something and it just works for the first time, you'd be like, oh, okay, that was cool. And it is cool, but you really learn stuff when it doesn't work. So if you have fun in the lab, purposely do stupid, crazy things with your configurations and watch what happens. What kind of responses do you get when this is wrong, when that's wrong? Don't be scared to, in your lab environments, break things. Don't do it in your production networks. If you're working for somebody and the network is not your lab, the network is not a science experiment. You gotta do it right in that setting. But in your lab, go nuts. You should break things and see what happens. You will learn a tremendous amount of things when things break. That's really fast forward your learning that way. All right, one last question for us to discuss, Holly. Where do default gateway addresses come from?
So it's a great question. But they come from, you can either configure it manually, if you wish to, with low CLI command.
And would assume then that you know what the default gateway is supposed to be.
Yes. But otherwise, the solution uses a protocol called DHCP, so Dynamic Host Configuration Protocol. So pretty much, it's going out and saying, hey, I need an IP address, and the DHCP server is saying, okay, well, I know that this is your IP address, your subnet mask, and your default gateway. So here we go. You can use this.
Yeah, that's the most typically where your IP address is going to come. Your default gateway is going to come from. Going back to our home router example, your home router has a DHCP, Dynamic Host Configuration Protocol, server built into it. That's part of what it does, and it sits there and listens for requests coming in from hosts like your laptop or your phone that are coming up on the Wi-Fi. And when your network device, your phone, your laptop, whatever, needs to is powered up for the first time or connected to your network for the first time, it needs an IP address, and it puts a pulse out on the wire. It puts basically a DHCP request on the wire and saying, "Hey, I'm thus and such a host." It knows its Ethernet address because it comes pre-programmed with one burnt into it, or its Wi-Fi radio address, and says, I need an IP address to go with this. The DHCP server that's on your home router is going to think, oh, yep, that's me. I'm a DHCP server, and I can give you one. And it will respond with an IP address and a mask and a default gateway. And a home router would have come from the factory pre-configured to send itself as the default gateway to include, it knows its own IP address and will include that IP address in the DHCP server field. For default gateways. And so that's how your computer will learn, my default gateway is my home router, because I was told it was via the DHCP response that it received from the DHCP server. If you're in an enterprise network, some network engineer that built the whole system out and knows what the gateways should be for all the different networks that you might find in your enterprise would have programmed that in, or worked with whoever the DHCP server administrator is to program in that bit of information into your DHCP server. And by the way, DHCP, Dynamic Host Configuration Protocol, can tell your computer lots of things, not just IP address and a subnet mask and a default gateway, but it will also tell you like DNS servers, which you need to be able to resolve host names to IP addresses. It will tell you that. And it can tell you there's all kinds of scopes or options. You will read DHCP options that are defined for a particular DHCP scope, a range of IP addresses that the server is serving for. So just something fun to go read about if you've not run into DHCP before. Okay, well, we've been talking about IPv4 and IPv6, Holly. Does IPv6 work the same way? Is it DHCP in IPv6? Because there is DHCP version 6. Is that also how that's going to work to for a host to learn, an IPv6 host to learn its default gateway?
So IPv6 uses NDP, so not
Mm-hmm.
DHCP. So it uses Neighbor Discovery Protocol to find out what that gateway is.
In this case, yep, Neighbor Discovery
Yeah.
Protocol. So IPv6 does use can use DHCP, but it's not going to learn default gateway via DHCP, the DHCPv6 server. It is going to use Neighbor Discovery Protocol. It is going to put it is a router solicitation message on the wire, basically going, "Hey, all y'all, I need a default gateway. Anybody out there a router?" And then a router will send a router advertisement message back in response to that router solicitation message and go, "Oh yeah, I am a router, and I'd be happy to be the default gateway." And there's a flag that would be set in there if it's meant to be used as a default gateway. And then that IPv6 host goes, "Ah, cool, got it. Router solicitation message told me what I needed to know." And DHCP would be used in conjunction with that as a separate protocol, filling in other blanks, specific IP addresses, and maybe your network range, depending. And NDP actually does that too. I forget all what's in the DHCP version 6 again without looking it up. I just remember it's different enough from DHCP version 4 to be annoying. So
yeah, I was going to ask some questions on it, but maybe we leave diving into DHCP and DHCPv6 for another episode.
Well, DHCPv4 I'm pretty okay on, but DHCPv6 I'd have to dig into a little bit just because I haven't actually administered one of those servers in anger. So, and I'm reading up on there are definitely differences there. But NDP is the thing you want to do some homework on in IPv6. That's how your host is going to learn that what its default gateway is. And by the way, you do not have to have a DHCPv6 server on the wire at all. IPv6 has got other mechanisms that you can assign an IPv6 address to a host. Slack is one of them. SLAAC is the acronym, and I don't remember exactly what it stands for right now, but effectively during that Slack process, a host can assign itself an IP address, and there's different ways you can assign yourself an IPv6 address to function on your local network and still be very confident that it's a unique address. It's not going to collide with anybody, and you don't have to have DHCP at all. It's just a lot of shops that came from an IPv4 environment and are used to DHCP have reasons where they'd like to use DHCPv6. Some of them are technical and very specific. Some of them it's comfort level. I used to have DHCP in version 4, and I still want DHCP in version 6. But there's not any one single right answer for address assignment in the v6 world. That was a lot of bonus material.
Yeah, I was going to say just quickly some more. Slack, stateless address auto configuration.
Ah, there we go. Thank you for that. I was reading it last night and I didn't write it down and I couldn't remember. Thank you for looking that up.
Sure thing.
And thank you out there for listening to N is for Networking today. If you have topics you want us to cover, would you send us a message at packetpushers.net/follow-up? We do have a very large list of topics we want to cover, and we would be happy to add your question to it. Check out all the other podcasts from the Packet Pushers by searching for Packet Pushers anywhere you get your podcast. We're on Apple, we're on Spotify. We really are everywhere. If you got a podcast client and you can't find all the Packet Pushers stuff in it, would you let us know? Because I've gotten a lot of trouble to make sure they're out there and everywhere. But at packetpushers.net, you can see all the shows too. There's a dozen shows now in our library. We're covering networking, we're covering security, we're covering wireless, DevOps, leadership, and all our shows are free for you. So subscribe to what appeals to you and let other people know. We would really appreciate that. I have been Ethan Banks, along with Holly Metlitsky. You can find us on LinkedIn or the Packet Pushers Community Slack group. And just remember, networking isn't hard. Other people figured it out, so you can too.